Alright, in this video I am going to go over the answers to review for quiz number 9. We begin with the first problem. It says a calculus student claims, that's a key word there, claims that the average, another key word, calculus book costs more than 200. Key phrase there. The population standard deviation, also key, is $28. A sample of 36 books has an average price of $220. At alpha equal to 0.01, test the student's claim. Well, the student is claiming that the average, the mean, costs more than $200. So the mean is greater than $200. That's the claim. Since it's greater than, it's an H sub 1 statement. H naught always has the equal sign, so mu equals 200. We write both of them down. Now we list out all our key values. Sample of 36 books, that's N, is 36. The average price is $220. The mean is 200. And the population standard deviation, that's sigma, is 28. We then calculate our test point using this formula. And I want to use a calculator to key in these values. So applying the calculator, the numerator we use parentheses. We type in 220 minus 200 divided by, once again, parentheses in the denominator, 28 divided by, now we apply the square root function, square root of 36, close the parentheses, hit enter, and we compute 4.29. So we draw the graph. We have to look up our critical value. It's a one-tailed test, alpha's 0.01. So we go to table F. One-tailed test, alpha's 0.01. Go all the way down to the z values, and that's 2.33. And so the critical value is right at the edge of the critical region and the non-critical region. 4.29, the test point, is greater than 2.33. Thus, it falls in the critical region. That informs us that we reject the null hypothesis. And then we summarize by stating there is enough evidence to support the student's claim. You can determine these summaries using the flowchart I supplied to you in the notes. Let's take a look at another problem. In this problem, it states a wildlife researcher claims that the average lifespan of a wild elephant is greater than 65 years. He samples the ages of 36 wild elephants and determines the mean age of the elephants in the sample to be 68. The population standard deviation is 8.6. Test the researcher's claim using alpha equal to 0.05. Use the p-value method. So our first step is to set up our claim. Once again, we see greater than 65, the average lifespan, so that's the mean is greater than 65, that's our claim. Since it's greater than, it's H sub 1. H naught is always the mean equal to the value. So it's the mean equal to 65. We get the key values here. We have a sample of 36 elephants. The sample mean is 68. Mu is 65. Population standard deviation is 8.6. It's a z-test. Remember, When sigma is given, apply the z-tests. We type in these values into our function or our test point, and we calculate it to get 2.09. We use the test point to calculate the p-value. So 2.09, we look up 2.09 in table E. Now when we look up 2.09 in table E, that always gives us the area to the left of that z value, 0.9817. But the p-value is computed using the tail area. So we take 1 minus 0.9817, 0.0183. And it turns out this is a one-tailed test. Therefore, this tail area is actually the p-value. So the p-value is 0.0183. Now, to make our decision, we have to compare the p-value to alpha. If the p-value is less than alpha, which it is in this case, we reject a null hypothesis. And then we summarize there is enough evidence to support the researcher's claim. All right, let's go on to the next problem. It says a jewelry store in Beverly Hills claims that the average age of its customers is over 38. A random sample of 25 customers yielded an average age of 45 with a sample standard deviation of 4 years. At alpha 0.01, can the claim be supported or not? Well, once again, it's saying that the average is over 80, so the mean is greater than, actually 38 here, so the mean is greater than 38. That's the claim. That's an H sub 1 statement, once again, because it's greater than, H naught has the equal sign, so mu is equal to 38. We gather up our key values. N is 25. X bar is 45. The mean is 38. And now we're provided with the sample standard deviation. So the sample standard deviation, that's S. That's equal to 4. When we are given S, we have a t-test. So now we have to compute the degrees of freedom, which is n minus 1. So 25 minus 1 is 24. And we look up the critical value in table F using the degrees of freedom and alpha. So it's one tail, 0.01. We go all the way down to 24. 2.492. And so we have a right tail test, 2.492. Remember, you always look at H sub 1. If it's greater than, it's a right tail test. And our critical value is right at the threshold. We calculate the test point, plug this information into the formula, and we end up computing 8.75. That is definitely in the critical region, but it's greater than 2.492. So our decision is to reject the null hypothesis, and we state that there is enough evidence to support the claim. Finally, in this last problem, it says the following. A statistician is testing the claim that the average amount spent by consumers during Black Friday is $400. She collects a random sample of amounts spent by consumers in dollars during the last Black Friday. So we have the data values listed below. We're testing the claim. Alpha is 0.10. So when you see the word is, you're thinking equals. So this example, the claim is the mean equals 400. That's our claim. Now, to write out our H sub 1 statement, the only option we have, the opposite of equals is not equal. So mu is not equal to 400. Now for the key values, the only value that we're really given is mu, 400. We have to use our calculator or Excel to compute the sample mean, the sample standard deviation, and n. N is easy. We could just count the values. 1, 2, 3, 4, 5, 6, 7. So n is 7, but we definitely have to use Excel or a calculator to compute these other values. I'm using Excel, so I already listed out the values in a separate Excel spreadsheet. Now to compute the sample mean, we type equals, type in the word average, parentheses, select the values, close the parentheses, and hit enter. So the sample mean is 513. The sample standard deviation, we use the function same diva. That's an abbreviation of standard deviation. Select the values. And I'll go ahead and round to 2 decimal places. 238.64. Now to determine n, you just type in count. I mean, obviously we can just count it ourselves, but Excel does have a count function, and that's going to be 7. We can now take this information, plug it into the formula, calculate, and we end up with 1.25. Now remember, since n is 7, degrees of freedom is 7 minus 1 is 6, and we have to apply a t-test because we needed to calculate the sample standard deviation S. So it's a two-tailed test. Let's look up the test point. Two tails, 0.10, we go down to degrees of freedom is 6, 1.943, and we have a negative 1.943 and a positive 1.943. 1.25 falls in the middle in this non-critical region. Therefore, we do not reject the null hypothesis. And using our summary chart, we say there is not enough evidence to reject the claim. And there it is, folks. Thanks for watching the video.